Today we're going to look at the Unit 6 review for probability. I want to make sure that you do watch this and go over each of these before you take the test. The first question says, Letitia has 2 bouquets of flower. Each bouquet contains 13 daisies. So I have bouquet S contains 30 flowers and bouquet T contains 13 flowers. So it's telling me out of there there's going to be 13 daisies. Well, this one has 13 flowers. All of them must be daisies. Bouquet S has 30 flowers, so we have 13 daisies and we have 17 that are some other flower that are not daisies. Which statement is true? So the probability of randomly selecting a daisy from bouquet S is less than the probability of randomly selecting a daisy from bouquet T. That is true because 100% is your chance here, right? So you're going to have a 1 as your probability. This is a probability of 1. 13 out of 13 is going to give me 1. Here, I would have 13 out of 30. We have a better chance of getting the ones that are not daisies on that bouquet S. So A is correct. Here, the probability of bouquet S is 1. That should have been T, and then that would have been correct. And then the probability of randomly selecting a daisy from bouquet S is equal to the probability, and we know that's not true. And then the probability of selecting a daisy from bouquet S is 1/3. That is not true either. It's 13 over 30, which is not equivalent to 1/3. Number 2, Mary bought 6 packets of tomato seeds. Each packet contains 24 seeds. She planted 1 packet of the seeds and 15 seeds sprouted. Which statement about the seeds in the remaining packets is best supported by this information? So we are going to use this information to say this is what's going to happen for all 6 packets. And then if it's 15 per packet sprouted, that means for 6 packets I would have 90 sprout, which is between 50 and 100. That's why I chose G, between 50 and 100. None of the other ones fit that data. Number 3, Felix has a bucket of golf balls. The table shows the number of golf balls of each color in the bucket. So Felix selects a golf ball at random based on the information in the table. Which statement is true? The golf ball is more likely to be green than any other color combined. Well, green is only 18. That is not going to give me all of them combined. It's not going to be that. B, the golf ball is equally likely to be pink, white, orange, and green. These would have to all have the same number in there, and they don't. They have different numbers for all of them. C, the golf ball is 2 times likely to be orange as it is pink. So orange is 8 and pink is 4. If I multiply 4 times 2, I would get that. So yes, it is twice as likely to get to pink. D, the golf ball is 7 times as likely to be green as it is white. That means I could multiply this by 7 and get the amount of green, which I do not have. That is not true. All right, number 4. A store manager receives a delivery of 2 boxes of light bulbs. Each box contains 25 bulbs. The store manager tests all the light bulbs and finds that 2 of them are defective. Based on these results, what can the store manager predict about the next delivery of light bulbs? So if we had 2 boxes with 2 defective, we're going to figure, right, 1 defective per box or 2 per 2 boxes. So that means for 4 boxes, I would have 4 defective or 2 additional, which is what I have here. A delivery of 4 boxes will contain 2 more defective light bulbs than a delivery of 2 boxes. And you can go over those and see that F, H, and J are not right, but I'm going to keep moving for time's sake. Number 5, Rachel is setting up tables for a party. 4 of the tables are covered with red tablecloths, and 8 of the tables are covered with white tablecloths. Guests will be randomly seated at the tables when they arrive. Each table can seat 8 guests. So we have 8 tables with 8 guests that are white, and that's 64 total seats of white at white tables. And then for the red, we have 4 tables with 8 guests each, and that's a total of 32 seats at the red, which means for a total, I have 96 seats. I just added the 64 and the 32 for 96 seats. What is the probability that the first guest to arrive will be seated at a table with a red tablecloth? So the probability of red is it's red over total, right? So my red is 32, my total is 96. I simplify that and I get 1/3. And that's just because 32 divided by itself is 1 and 96 divided by 32 is 3. B, 1/3 is the correct answer. Number 6, Mildred has a bag of coins. The bag contains 10 dimes, 5 nickels, and 1 penny. She will randomly select 2 coins from the bag, one at a time without replacement. What is the probability that Mildred will select a dime first and then a penny? So we have the probability of dime and the probability of penny. So I have 10 dimes out of 16 coins. She does not replace it. So when it comes to the penny here, there's only going to be 15 total coins now, and there's only one penny, so 1/15. And I did simplify 10/16 to make my math easier. That becomes 5/8. So I need to multiply when I'm working on these probabilities like this. And I have 5/8 times 1/15. 5 times 1 is 5. 8 times 15 is 120. I need to simplify that, and I get 1/24. So J, 1/24 is the correct answer. Number 7, Tara has 2 bags of marbles. The first bag contains 6 red marbles, 5 blue marbles, and 4 green marbles. The second bag contains 3 red marbles, 2 blue marbles, and 4 green marbles. Tara will randomly select 1 marble from each bag. What is the probability that Tara will select a blue marble from each bag? So I've got my first bag, and I've got 6 reds, 5 blues, 4 greens. In my second bag, 3 reds, 2 blues, 4 greens. Total of 15 marbles in the first bag, and a total of 9 in the second bag. Remember, I want the probability of blue and a probability of blue. So I have blue is 5/15, simplifies to 1/3. Second bag, blue is 2/9, and I'm going to multiply again. 1/3 times 2 9ths. 1 times 2 is 2. 3 times 9 is 27. There is a 2 in 27 chance that she will select a blue marble from the bag, each bag. Number 8, on Roberto's shelf are 6 mystery books, 5 science books, 4 history books, and 3 adventure books. Roberto will randomly choose 1 book to read. What is the probability that he will choose an adventure book? So the probability of adventure is adventure over total, 3/18, which simplifies to 1/6. J, 1/6 is our answer. Number 9, Gabriel has these cans of soup in his kitchen cabinet. So we have 2 cans of tomato, 3 cans of chicken, 2 cans of cheese, 2 cans of potato soup, and 1 can of beef. That's a total of 10 cans. Gabriel will randomly choose 1 can of soup, then he will put it back and randomly choose another can of soup. What is the probability that he will choose a can of tomato and then a can of cheese? So he replaced it, so our total is not going to change when we're doing these. The probability of a can of tomato is 2/10, which simplifies to 1/5. And the probability of a can of cheese is the same 2/10, which simplifies to 1/5. And that's just grabbing these right here. And then I need to multiply. 1/5 times 1/5. 1 times 1 is 1. 5 times 5 is 25. Our answer is C, 1/25. All right, number 10, Jack tossed a coin 3 times. Which tree diagram shows all the possible outcomes of the coin landing heads up or tails up? So right here, this was close, but we didn't get a tails here. So this is essentially the same tree twice. This one here has me starting with tails, but it never shows me starting with heads. This one here shows me starting with heads all the way through, right? Heads, tails, heads, tails. And then I have the tails as my first one. So this one is correct. And then J forgets the landing tails first. So, or H is our correct answer. Number 11, Bailey will roll a number cube and flip a coin for a probability experiment. The faces of the number cube are labeled 1 through 6. The coin can land on heads or tails. If Bailey rolls the number cube once and flips the coin once, which list contains only the outcomes in which the number cube lands on a number greater than 4? So if you see any numbers 4 or less, I have to eliminate them. Okay, so far here, C, we've got 1, 2, 3, and 4. We have to eliminate C. D has 4 included. We've got to eliminate D. So now let's look at A and B. So A has my 5 heads and my 5 tails, and my 6 heads and my 6 tails. So this is complete. B, on the other hand, it's got our 5 for heads, but it's missing 5 tails. It has our 6 tails, but it's missing the 6 in heads. So A is the correct answer for number 11. Number 12, 3 of Miss Kramer's classes are going on a field trip. Each class has an equal number of boys and girls. Miss Kramer is creating groups that have 1 student from each class by randomly selecting student names from a list. Which simulation could Miss Kramer use to create the groups for the field trip? I've got it written for the other ones. I'm going to only talk about the correct answer. G, roll 3 number cubes where each cube is 1 class. The even numbers on the number cube represent a boy, and the odd numbers on the number cube represent a girl. So we've got 3 classes. So each roll, she's going to get a boy and a girl, and there's an equal amount of possibilities in getting an odd number or an even number. So this would be a good way to randomly select it using the number cubes. 13, we have a study of a population of 1,200 frogs or 1,200 frogs revealed that 12 out of every 180 frogs in the population have spots on their back. Based on the results of the study, how many frogs in the population do not have spots on their back? So the probability of spots is 12 out of 180, which simplifies to 1/15. So the probability of not having spots is 1 minus, right? So it's 14/15. And I took the knots and I multiplied them times the 1,200. And then I got 14 times 1,200 is 16,800. 15 times 1 is 15. Then I divided, and when I divided 16,800 by 15, I got 1,120. So D, 1,120 is correct. Number 14, at an assembly, 7 out of the first 10 students who entered the gym were carrying a backpack. Based on this information, if 700 students were at the assembly, how many students could be expected to be carrying a backpack? So when we are given this data here, we're going to assume it's always correct, right? We're going to assume, is it likely to be correct? No, but it's going to give us a close estimation on what it would be for those 700 students. So we're going to take the probability of a backpack as 7/10 and multiply that by 700. So 7 times 700 is 4,900. 10 times 1 is 10, and then I need to divide. And so that's just right like that, 490. So we would say about 490 students. 15, the spinner has 8 congruent sections. The spinner is spun 120 times. What is a reasonable prediction for the number of times the spinner will land on an even number? So the first thing I did is identified which ones were odd and which ones were even. So I counted that I had 5 odds and I had 3 evens, and I have 8 total, right, sections. So the probability of an even is 3 out of 8. So I'm going to spin it 120 times. So 3 8s, 120 times to find out how many times it will land on even. 3 times 120 is 360. 8 times 1 is 8. Divide. And 360 divided by 8 is 45. So right here, 45 times. 16, a bag contains 5 red marbles, 6 blue marbles, 3 green marbles, 4 black marbles, 2 yellow marbles. That's I added them up. I had 20 total marbles. A marble will be drawn from the bag and replaced 100 times. So it's replacing, so that total 20 is never going to change. What is a reasonable prediction for the number of times a green or black marble will be drawn? So remember, when we're doing or, we need to include both of them. So I have 3 green and 4 black. That's going to be 7. So I have 7 out of 20, and that's 100 times. So 7 times 100 is 700. 20 times 1 is 20. And then I divided, 700 divided by 20, and I got 35. So 35 is a reasonable prediction. Number 17, the spinner shown is divided into congruent sections that are labeled from 1 through 7. If the spinner is spun 1 time, what is the probability of the arrow not landing on a section labeled with an odd number? So a probability of not odd. Again, I determined which ones were odd. I had 4 odds, 1, 2, 3, 4, and 3 evens, and I had a total of 7 sections. So the probability of not odd is the 1 minus the probability of odd. So the probability of odd, and you could have done this just like this. 1 minus the probability of odd. The probability of odd is 4 out of 7. That's my odd. And then I do 1 minus, so that's 7 over 7 minus 4 over 7 equals 3 over 7. But I could have as easily done, sorry, that should have been even. Probability of even, which means not odd, correct? And then even is 3 out of a total of 7. So either way, this is going to work. Number 18, the table shows the types of movies and the numbers of DVDs rented by customers at a store in one day. So here we've got this. Based on the data in the table, what is the probability that a random customer will not rent a drama? So the probability of a drama, and then I need to say the probability of non-drama. So there's 25 that were drama rentals, and there was a total when I added up of 125. So the probability of a drama is 25 over 125, which simplifies to 1/5. The probability of not a drama is 1 minus 1/5. So 1 is equivalent to 5/5, minus 1/5 is 5 minus 1 is 4/5. So the probability that a random customer will not run a drama is 4/5 because the probability of running a drama is 1/5. All right, number 19. Brandon has a spinner that is marked with colors red, green, and blue. Based on this information, which statement must be true? So pretty much A through C, we don't have enough information to answer any three of those because we don't know about the sizes of these red, green, and blue. We could have a spinner and we could have it set up like this maybe, where this is red and we've got blue here and green here. Well, I'm going to have a much greater chance of getting red if it's set up like this. But we can say the probability of blue plus the probability of not blue is 1, because that covers everything on the spinner. So D is the correct answer. Number 20. Brandy wants to participate in an after-school program. She has to choose between 1 art class, 3 dance classes, 2 gymnastics classes, or 3 sports classes. She cannot decide, so she writes the names of each class on a slip of paper and draws 1 slip out of a bag. What is the probability that she does not draw a dance class? So I wrote each of these out. I've got art, dance, gym, and sports. I added them up. I have a total of 9 different classes. So the probability of dance is 3 out of 9, which simplifies to 1/3. The probability of not dance is 1 minus the probability of dance, so 1 minus that 1/3. 3/3 minus 1/3 is 2/3. So she has a 2/3 chance of not drawing a dance class. All right, I know I went over this quickly. If you have any questions, please send me an email. Probability can be confusing, but if you take your time and work out each of those problems, I think you'll do well. And have a great day.